In the next two examples, we're dealing with functions that have point discontinuities, curves that would otherwise be continuous except for a single point that's missing. What we want to do in part A is find the limit of this function as x approaches 1 from the right. So in this case, we're approaching a function value of 3. As we approach 1 from the left, we're approaching that same function value of 3. Since the two one-sided limits are equal, that tells us the limit as x approaches 1 is also equal to 3, despite the fact that our function value at x equals 1 is going to be negative 3, because we have that point that's separate from the rest of the curve telling us what our function value is at negative 1. We have these specific examples that we've chosen and we're using to make sure we see this potential disconnect between the limit value and the function value. It's possible for one to exist and the other to not exist, or for those two values to both exist, but just be different from each other. In example 4, we have another potentially tricky case, because here what we're actually investigating is the limit as x approaches 2. So we want to investigate what's happening at this point, which is a smooth continuous curve, or a smooth continuous point on the curve, just like we had in example 2. So we'll consider the limit as we approach from the right, which will be about 2.5. As we approach from the left, which will be 2.5. Since the two one-sided limits are equal, the limit as x approaches 2 is also 2.5. And since this is a smooth continuous part of the graph, our function value at x equals 2 would be exactly the same as the limit value at that point.